Hi all, in this video we are going to discuss what is function and what are all the types of functions, and for cbse students this concept will be useful for you all for the first two chapters. Okay, after this we'll start with the second chapter. Suppose if anyone asks you how you both became friends, like we say either the classmate or any other events if you have met, or any other classes like dance class or music class or whatever, or the family friends or the neighborhoods, like some or other way, like we need a something or some event or some mediate to connect, isn't it? So same way in mathematical term, function, the connecting the two sets in some particular function. Okay, so that function can be of any form. Okay, so we have relations and functions, which are all functions, which are all not a function, which are all relation, which are all not a relation. So that is the main topic in this concept. Okay, so we have two sets and we connect it in some function. So that connects or relates one set to another set in a particular way. Okay, example, we can have states and its capital. Okay, so states we can have as first set A, and capitals we can have it as the set B. So what is a set? As you all aware of set, we will be like mathematically will represent in curly braces with a comma. So there will be no repetitions. You can not only use the alphabets or numbers or the names as we have discussed in the previous example, the capitals, the names of your class students, the fruits, the companies, whatever it may be. Okay, so we need to enclose in the set braces and with a comma. That is very important. And we have two types in that set: finite and infinite set. Finite is like you'll have finite number of terms, the letters of English alphabets or number of students in a classroom, that are all like a finite set, isn't it? And infinite set of all real numbers, set of all integers, like we have minus infinity to plus infinity, isn't it? So we have the finite and infinite set. So this is just to brush up this concept. As we involve sets in the function, you should be aware of that topic also. Okay, as I said, from one set to other we are linking, isn't it? So from which set you are starting, that we will take it as input. Okay, this is just for your understanding. Okay, you are feeding some data in your system and you are getting some results, isn't it? So feeding the data is in your input and you are getting some results, that will be the output. Okay, in between the processing, that is what the function. Yeah, same way here also, this function is, it takes the value from the first set, okay, and relates and gives us the answer, and it will be in the second set. Okay, for example, we have set A 1 2 3 4 5 and set B A B C D. So 1 is related to B, 2 to A. So we can also write 1 comma A, 1 comma B, 2 comma A. Representation of this function, we have 4 types that we'll see in the next topic. So here the first set should be given the priority because from there only we are picking the elements. So that is termed as domain. Okay, and it is mapped, isn't it, to the second set. What are all the mapped elements? Those are all the range, that is from the codomain. So overall the set B we say it as codomain, and the mapped elements we say it as the range. For example, we have two sets C and D. C as class 12, 11, 10, 9, 8, etc. and D as 20, 40, 31, 30, 35, 25, 45. Okay, that is the class and respective strength from C to D. So C is the first set, then it is domain. D is the second set, then it is the codomain. Okay, so we have only 12, 11, 10, 9, 7. Okay, sorry, 8. 5 classes are there. According to the strength, we have matched here. Okay, but if you see this 130, 20 is not mapped. So overall the second set is the codomain, and the mapped elements, again we write it in set braces to indicate. So only the mapped elements in the second set is range. Overall the elements in the second set is the codomain. Okay, so when we say codomain and range are equal, in the previous example, if you see all the elements in the codomain are mapped, isn't it? So in this case, codomain and range are equal. Otherwise, the range always will be less than or equal to codomain. We have the representation of the function in arrow diagram or in tabular form or in ordered pair or in graph. Okay, so in arrow diagram, the first set the domain, the second set codomain. So whatever they have given, accordingly find the answer and map those. Okay, in tabular column, we'll just write the first set. Either you write it as B or we can write it as f of A. This f of A means that we are substituting the elements from the domain in the function and finding the value correspondingly. Okay, so that is the meaning of f of A, function of A. Correspondingly, you just write the value. Okay, it can be x and y or it can be A and B, that's up to you, or whatever they have given in the question. And the function is actually from A to B. This I have to say it in the beginning itself. Sorry. So A, we have the set A, B, C, D, and B as 10, 20, 30, 40. Okay. So here, in ordered pair, you just write, don't forget, in brackets, you need to mention like how we used to write x and y coordinates. The same way, domain and range. This is the condition and enclosed in the set braces. That is important. And in graph, in x-axis we plot the domain and in y-axis we plot the range. Okay, and map the plot the points accordingly. We have few examples. Function, not a function. Okay, so y is equal to 10x. Either you can say it as y is equal to 10x, as I have mentioned earlier. You can also use, as it is x, you can mention f of x. Either you represent y or f of x, both means the same. Okay, and the function here is from A to B. If suppose they have mentioned as natural numbers or if they have given the numbers for domain, substitute here. So 10 into 1, 10 ones are 10, 10 into 2, 20, 1 into 10, 10, 2 into 10, 20, 3 into 10, 30, 4 into 10, 40. Correspondingly map. This is by the arrow diagram. Okay, so from, if you are seeing your mirror, from where we are standing and seeing the image of ourselves, so from where you are seeing, we say our image, we are seeing our image, isn't it? So from domain to codomain, if you are taking, then image, 10 is the image of 1, 30 is the image of 3, 40 is the image of 4. Okay, from mirror point of view, from there if you see, it is the pre-image. So from the set B, if you are saying, then 2 is the pre-image of 20, 3 is the pre-image of 30, 4 is the pre-image of 40. So from codomain point of view, it is pre-image. From domain point of view, it is image. And here if you see, y equal to root x. So this is like an important part, where we see it is not a function. Y equal to root x, or you can write f of x equal to root x, and as usual we have f is a function from A to B. Okay, so for square root of 0, it is 0. We don't have any plus or minus specifically for 0, as we all know. And suppose if I take 4, as it is a square root, we have plus 2, minus 2. For 5, it is not a perfect square, so we have plus root 5, minus root 5. 9, again it is a perfect square, plus 3, minus 3. So from domain, the element should be mapped only once. That is, if 4 is mapped to 2, then 4 should not be mapped to any other elements. Kindly note, from domain, the elements should not be mapped more than once for a function. Okay, here if you see at least one element if you have in that case, then also it is not a function. Okay, say for example, if 4 alone have 2 and minus 2 other have only one image, then also we say it is not a function, as 4 have 2 images. So element from the domain should not have more than one image. That is the criteria for the function. If this is not a function, we can take it in the relation concept. That is different. But this is not a function. From domain, the element should not be mapped more than once. So in types of function, mainly we will have this 1 to 1 and on to. So that we'll discuss now. So one-to-one function is, first we'll see the example. In this example, we have the function from period to the corresponding teacher. So period set we have maths, physics, accounts and chemistry. In second set teacher, we have Mr. Anish, Ms. Kirti, Mrs. Selvi, Mr. Rakesh, Ms. Ritu, Ms. Chitra. Okay, so maths is taken by Ms. Kirti, physics by Mr. Anish, accounts by Mr. Rakesh, chemistry by Ms. Ritu. Okay, so here if you see, in domain for a function, all the elements should be mapped and it should be mapped only once. Okay, so all should have the unique image. So maths is taken by Ms. Kirti, then physics also should not be taken by Ms. Kirti. Actually there is a function, not one-to-one. So maths, if it is mapped to Ms. Kirti, so then that should not be mapped with any other element. Ms. Kirti should not take other subjects. Only maths she should take. Same way with Mr. Anish, he is taking physics. So other than physics, he should not take any other subject. Okay, so this is the concept of one-to-one function. So all the elements from domain should have unique image. Unique image in the sense, other elements should not have that image. So that is, other subjects should not be handled by Kirti. Okay, and if you see in the teacher set, we have Mrs. Selvi and Mrs. Chitra is not taking any classes with respect to these subjects, isn't it? That is not a problem. If any elements left out without mapping in the second set, that is not a problem for one-to-one function. Two things are there for one-to-one function. First one is all the elements should be mapped from the domain. That is the default condition for a function. Second point, all the elements should have unique images. And if you see, this is the example for only one-to-one function and not for the on-to. A function that is f is from A to B is said to be one-to-one, or we have the name injunctive function if all the elements in domain, that is the set A, have unique images in the codomain, that is the set B. That is, for all x1, x2 belongs to A, f of x1 equal to f of x2, that is x1 equal to x2. So for on-to also, we'll see the example, then we'll come to the definition part. For on-to, we have the two sets. Function is from service to the type. So service is Spotify, Netflix, YouTube, Jio7, and in type we have audio streaming and video streaming. Okay, so all the elements are mapped only once, so it is a function. And if you see, Spotify and Jio7 are audio streaming, isn't it? We'll listen the songs. Netflix and YouTube are video streaming. Okay, that is not our problem now. Here if you see, Spotify also have the audio streaming, this image, and Jio7 also have the same image. Okay, so more than one element from the domain have the same image. Yeah, but if you check with the codomain, all the elements have at least one pre-image. At least one pre-image. Like the previous example, the two teachers are left out with no subjects, isn't it? They don't have any subject in the domain set. But here, audio streaming has Jio7 and Spotify. Video streaming has Netflix and YouTube. So both have at least one pre-image in the domain. So that is what the on-to function. As the elements from the domain have no unique elements, unique images, that is for Spotify also audio streaming, Jio7 also audio streaming. So both have the same image. It is not unique. So the function is not one-to-one, but this can be taken for the on-to function. Function f is from A to B is said to be on-to or surjective function if every element of set B have at least one pre-image in the set A. That is, for all y belongs to B, there exists x in A such that f of x is equal to y. The reverse way we take. Can a function be one-to-one and on-to? Both are possible? Yeah, we'll have the example here. So we have the function from set A to set B. Set A is class and set B is the post they have. So class 9, 11, 12 and 10 have the school people leader, assistant school people leader, sports secretary and assistant sports secretary. So all have the single post. No one person can hold the school people leader and assistant. One cannot be same leader and assistant, isn't it? So all the students, like students representing each class, have only one post. That is a unique image. Condition for one-to-one is satisfied. And for on-to, from the codomain, all the elements have at least one pre-image. On-to function condition also satisfied. So this example can be taken as for one-to-one and on-to function. Can any function be neither 1 to 1 nor on 2? Yeah, that is also possible. We have the function from A to B. So from A, we have the classes, and from set B, we have the subjects. Okay, so for class 12 and 11, we have physics, and for LKG and UKG, we have storytelling and rhymes. LKG and UKG, the elements from domain have unique images. But if you check with these two classes, both have physics, that is, both have the same image. So it is not 1 to 1. And also, if you check with the codomain, these elements have no three images in the set A. So it is not on 2. So this is neither 1 to 1 nor on 2. Now we have the main topic, inverse of a function. Okay, so when a function is both 1 to 1 and on 2, we say bijective function. Okay, so if a function is bijective, then we say inverse exists. So for a function, f is from A to B, if it is a bijective function, that is 1 to 1 and on 2, then there exists another bijective function. That is, as I said, it is inverse, isn't it? So that will be the reverse way. So from, as I mentioned earlier, from the image mirror point of view. So from B to A, such that for function we write f of x is equal to y. The reverse way, f of y is equal to x. The same function we cannot write. So g of y is equal to x. Just replacing x and y position. Okay. If and only if f of x equal to y. That is 1 to 1 and on 2. So g is a function from B to A is the inverse of f is a function from A to B. So we can denote it with f inverse, power as minus 1. So this inverse, this is the topic for CBSE class 12 students, second chapter. So normally in trigonometry you would have studied in class 11. Yeah. So for y is equal to sin x, we have the range 0 to infinity and 0 to minus infinity, both on x and y. So we have the values correspondingly. So this is for y is equal to sin x. The alternative way, the sin inverse x, the opposite way we have. So these pi values will be in the y-axis and this y values will be in the x-axis, minus 1, 0 and 1. So the graph will become like this, the opposite way for the cos x function. Here also you have the reverse way for the inverse function. These values we would have studied in class 11 itself. So for sin theta, the domain and range, real numbers, minus 1 to 1. For cos theta, real numbers, minus 1 to 1. For tan theta, we will not include the values whichever for cos it is 0, because tan is sin by cos, isn't it? So denominator should not be 0. So for cos, the multiples of pi by 2, 2n plus 1 into pi by 2. So those values will become 0. So that we are neglecting. And for cot, it is like cos by sin, isn't it? So for sin, what are all the values will make it as 0. So those values n into pi. So n is integer here. It can be both minus and plus. Secant again, it is 1 by cos. So this tan and secant, we have the same eliminations. For cot and cosecant, sin is in the denominator. So these domain will be the same. Okay. But for tan, cot, we have the real numbers. For sin and cos, the closed interval of minus 1 to 1. For secant and cosecant, except minus 1 to 1, we have the other values. This domain and range, you should be thorough to solve the first exercise. Okay. So this is just the opposite way. What are all the range here, you will be taking it for the domain. What are all the domain we have, with some points neglecting, we will have it for the range. Okay. So domain minus 1 to 1, range is minus 90 to 90. Cos for minus 1 to 1, closed intervals 0 to 180. For cosecant, excluding the minus 1 to 1, secant also, we have corresponding values for the range. So make sure you are thorough with this table, so that for solving 2.1 exercise, it will be easy. Other than that, if you have any doubt, please post it in the comment section. Thank you.